In this video, I will show you how to solve systems of equations like this one using matrices, and specifically the inverse matrix. Well, first of all, you need to know how to take a system and write it as a matrix equation. So we will start with the coefficients. We can make a matrix out of these coefficients by writing 4 and 6 and 2 and 5. So that's a matrix. What happened to the variables, you ask? Well, they will make their own matrix, alright, in order, x and y, like that. And if we were to use our matrix multiplication and multiply these together, we would actually get exactly what we have above. And then we will have a third matrix made out of the answers over here, the 24 and the 8. Now, similar to a linear equation, just an algebra equation, let's call this matrix A, and I'll call this matrix V for variable matrix, and let's call this matrix B. So my matrix equation is matrix A times matrix V is equal to matrix B. Now, if these were real numbers and not matrices, if I wanted to get V by itself, I would just divide both sides by A. But you can't divide with matrices. That's not a thing. Instead, what you can do is use inverses. Now, one of the things that we have learned is that if you multiply a matrix by its inverse, you're going to get the identity matrix. So what I can do is multiply both sides of the equation by A inverse. Now, A inverse times A, that's just the identity matrix. So they basically cancel each other out. So we're left with matrix V, the variable matrix, is equal to A inverse times B. So this is what we will use to find the variable matrix and solve the problem. We will find A inverse, and then we will multiply that times matrix B. So how do we find A inverse? Remember, finding the inverse of a 2 by 2 matrix has two steps to it. First, we have to find the determinant. Maybe I'll do that off to the side. We'll need to find the determinant of matrix A. And that worked like this. You have to do the down diagonal minus the up diagonal. So the determinant was going to be 20 minus 12, which is 8. Okay, so fine. Now I have the determinant. Now, to find A inverse, I need to do the reciprocal of the determinant, which is 1 over 8, times what I call the reverse negate matrix. Reverse negate. Back in the day, there was a song called the Cha-Cha Slide, and there's a part in the middle of the song where they would say, reverse, 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 and everyone would spin around. It was lots of fun. Whenever I learned about matrices, and I saw that we had to reverse and negate, I couldn't help but say, reverse negate, reverse negate. And plus it helps me remember what to do. So here's what I mean by reverse negate matrix. Okay, so I'm talking about the down diagonal and the up diagonal. So this is the down diagonal, and this is the up diagonal. So I am going to reverse the down diagonal and negate the up diagonal. If I reverse the down diagonal, that means I just switch these numbers. So this will be 5 and 4. And then I'll negate the up diagonal, meaning change the signs. So this will be -2 and -6. Okay, so for A inverse, I need to multiply all these by 1/8, or in other words, divide them all by 8. So that's going to make 5/8 and -6/8 and -2/8 and 4/8, which of course means that A inverse is, I'm just reducing, so of course 5/8, that doesn't change, but then I'll have -3/4 and -1/4 and 1/2. Okay, so this is A inverse. Okay, so what we need to do now to find the variable matrix, I need to do A inverse times B. So I'm going to take this A inverse, so I'm just going to recopy it real quick. And I need to multiply that times matrix B, which is the 24 and the 8. Okay, so this is A inverse times B. Okay, I'm going to have to erase some of this stuff over here because it's in my way. Okay, the dimensions of matrix A inverse are 2 by 2. The dimensions of matrix B, 2 by 1, right? 2 rows, 1 column. This is good because the inner dimensions have to be the same. But the outer dimensions tell me the dimensions of my final answer. Alright, so see how the outer dimensions are 2 by 1. That means my final answer is going to have 2 rows and 1 column. So I'm going to set up kind of a rather large 2 by 1 matrix in which I will do my work. Okay, here's a rather large 2 by 1 matrix, 2 rows, 1 column. Okay, so look guys, all of my rows are going to come from the first matrix, and all of my columns, well I only have 1 column, but all of my columns will come from the second matrix. So check this out. I have row 1. Row 1 belongs in row 1. I'm going to write it vertically even though it's a row, so don't get confused, don't get it twisted. So row 1 is 5/8 and -3/4. So row 1 goes in row 1. I'm just going to stick with rows for a minute. So now I'm going to do row 2. Row 2 belongs in row 2. So I'm going to put my -1/4 and my 1/2 in row 2. Now I'm going to do my columns. Column 1 goes in column 1, all the way down column 1. So column 1 is 24 and 8. So I am multiplying by 24 and I am multiplying by 8. And I'm going to put it all the way down column 1. So that means I'm also going to do it here and I'm also going to do it here. Okay, so now I'm going to multiply these together and see what I get. Notice that 8 goes into 24 3 times. Right? So 8 goes into 24 3 times. 5 times 3 is 15. 4 goes into 8 twice. -3 times 2 is -6. Then I'm going to add those up, and that's 9. 4 goes into 24 6 times. So this is going to be -6. And of course half of 8 is 4. So add those up and that's going to be -2. So my variable matrix V, remember, is what we were finding, turns out to be 9 and -2. So that means, you know, considering that matrix V was X and Y, that means X is equal to 9 and Y is equal to -2. So that's how you use matrices to solve systems of equations. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.